So if you're given these points and they're told it forms a triangle, find the desired slopes and lengths, then fill in the words that characterize the triangle. So they're going to say, find the slope for everything, find the distance for everything, and then using your definitions here, tell me what kind of triangle is it. So is it an equilateral? 3 sides are the same. Is it an isosceles? 2 sides are the same. Is it a scalene? No sides are the same. Is it a right isosceles, meaning in terms of the 2 sides being the same, there's also two sides that form a 90 degrees. Is it an equilateral right triangle? That means all the sides are equal and one of the sides forms are 90 degrees. Is it a scalene, which means none of the sides are equal and one side forms are 90 degrees? So that is what it's doing here. Now, I'm going to actually do this question, but I'm going to be fast with it because, again, this is the pre-work. All we're doing now is just knowing what kind of shape it is so we can classify. So as always, as I do example 1, you go ahead and do example 2. What I'm going to do with example 1 is I'm going to put it all in the calculator and then I'm going to transfer my work over just for speed purposes. So I have point R, which is equal to -4, 1. I'm going to copy that real quick. Then I have point S, which is equal to -3, 9. Then I have point T, which is 3, 5. If I want to see it in decimals, I type polygon because that's what it's called. Polygon in lowercase, and then I put in parentheses my points R, comma, S, comma, T, and it'll join it for me. So it is a triangle, and looking at this triangle, it may be an equilateral, or maybe this side is equal to this side is what I'm looking at, and it's definitely not a right. So I'm doing all of this work, however, I can visually see. So it might be worthwhile learning how to just type in polygon so that you can see what you need. But it's either an equilateral or this side is equal to this side. Again, remember you can do labels. So those are labels with my points. You can do labels with the letter. So that's R, that's S, and that's T, but totally up to you what you want to do. All right, so if I want to know what kind of triangle it is, I need to know, I'm thinking right now it's definitely not a right, so I don't need to prove that, but I'm going to prove this side is equal to this side because I think it's isosceles. So I'm looking for the distance SR. So for right now, I'm actually going to take off these labels and I'll put them in at the end and put in the label with the coordinates, because once I have that, I can hit my table for organization. I'm really looking at -3, 9, -3, 9, and -4, 1. Let me find this distance right here. So again, I do SQRT, or you can type in square root, parentheses, squared, shift 6, plus parentheses, squared, shift 6 with a minus sign inside. And again, anytime you're doing this for the first time, you double check it with your formula. So I'm looking for the distance formula. I have square root, parentheses squared, plus parentheses squared with a minus inside, x in my first, y in my second. So in my first, I need my x's, -3, -4, and keep the negatives. And then I need my y's, 9, 1 in the same order. All right, so that's my first side. Then I want from here to here. So -4, 1, I already have it. So I'm just going to delete this one. And I'm going to go, I want 3, 5. All right, so now I'm going to repeat the same thing, and I should have copied this formula the first time, but I'm going to go ahead and do it right now. So I'm going to hit that, copy, and then I'm just going to delete the x's and y's. I should have done that the first time because I knew I was going to do this a couple of times. Actually, I might check to see if it's equilateral, so I'm going to do it one more time as well so that it's already there. All right, so again, my x's, -4, 3. My y's, 1, 5. All right, so yes, those are the same. So far I know it's definitely isosceles, but is this one the same? So this one is 3, 5 and -3, 9. So 3, 5 is already there. I just need to delete that and put a -3 and 9. Putting in my last one, x's is 3, -3. Y's is 5, 9. All right, it's not the same. So I've definitely proven that it's isosceles because these two sides are the same. Now, I don't remember what sides they are. I can label them. So I can say R, S, and T. So SR and RT are the same. SR and RT. So these ones are the same right here. All right, and I can just copy my work in here. All right, so that's really what I'm saying. So to prove the distance here, all three distances, now I'm going to prove the slopes, even though I can visually see. So if I'm on a test, I'm not wasting my time doing the slopes, but I do want to show it to you in case yours has a 90-degree angle. So I am going to show that. But let me just quickly copy my work into my paper. So again, to show that on this diagram, RS is congruent, which a tick mark, to this one 8.1, which is TR. All right, what is the perimeter? Okay, so again, we have our three sides. What is the perimeter? And because I want us to practice simplifying radicals, we're going to do this in radical form, which means I need a radical in the answer. You can do SQRT or you can type it in. What's the radical that goes in there? 65. But again, I'm still going to do this really fast. So 65. I know 5 goes into 65 13 times. But you can keep breaking it down. But for me, I'm doing it the faster route. There are no books, so the most simplified version is radical 65. So I don't need that anymore. I know that this is the same as this one, so I'm just going to do 65 in here. Then for this one, and again, if I'm going too fast, it's because you need to practice on the previous ones. On this one, it's going to be 52. All right, so 52 is going to be what? 25, 26 times 2. Okay, maybe this one I'm going to do. All right, 52 divided by 2. That works. 26 divided by 2. 13. Okay, so it's 2, 2, 3. 2 times 2 times 13. Sorry. All right, yep, I'm matching, so I'm good. I see a book of 2, so this is 2 radical 13, and I can get rid of that. All right, so the perimeter is going to be radical 65 plus 2 radical 13 plus radical 65. And because the radicand, the number underneath the radical, is the same for those two, I can add them up. So this is an invisible 1. So it's going to be 1 plus 1, which is going to be 2 radical 65s plus 2 radical 13, which is approximately, if I put all of that together, 23.33. 23 point, let's do the nearest tenth, so 3. Now to check that with my answer, I should have 2 radical 65s. Is it the same thing? Yes, it is. All right, so I do want us to keep practicing simplifying radicals. The Delta Math will practice the decimal versions. All right, so let me go ahead and do the slopes real fast. So for the slopes, I don't need these. I already have one in there, so I'm going to put my labels back for what I need. All right, so I have 3, 5. Let's see which one that one was. All right, so I have 3, 5 and negative 3, 9. If I want to prove that they are 90 degrees, okay, the slopes must be reciprocals of one another. So I've got these two. Now I need to do this one. So I need negative 4, 1 and 3, 5. So I'm going to put in another table. Negative 4, 1. And again, if I'm going too fast for you, it's because you just need the previous videos. If these slopes are reciprocals of one another, then they are right angles. So I can already see that these are not going to be, but I'm just going to prove it to you. So you bring it to a new line. Let's make that a fraction. That looks weird. Continue that 6. That's the number. Let's get this one. That looks weird, but there's no pattern to continue. So if these were reciprocals of one another, negative 2 over 3 would have been, flip it over, which is 3 over 2, and change the sign to positive, and you could multiply them to negative 1, but they are not. So the slope for these two, which is TS, 3, 5, negative 3, 9, 3, 5, negative 3, 9. So this one. So TS is going to be negative 2 over 3. So TS or ST is negative 2 over 3. The slope for this one, which is negative 4, 1 and 3, 5, is going to be something that I have to do because it's not defined. And then let me find the slope for the last one. So let me hit in another table. And we're going to do negative 3, 9 and negative 4, 1. And that slope is going to be 8. So that's going to be negative this 2 right here, which is SR. SR is negative 8. And I need to find this other one by hand. So even though this is not a right triangle, I can see none. This is not a right angle. This is not a 90-degree angle. That's not a 90-degree angle. I'm going to show you how to find it in case yours is. So in order to find 90-degree angles, if something is perpendicular, I need to see that the slope has reciprocal values. In other words, you can flip and change the sign. So I need to find the slope in all of these angles right here. So I'm going to do 3 of them. So I'm going to have 3 tables. All right, so I'll just start from here. So -3, 9. And I'll go here. So -4, 1. And then I'll go from -4, 1 to the next point, which is 3, 5. Then I'll go from 3, 5 back to my beginning, which was -3, 9. All right, so I already know what I know, but I'm just going to go ahead and put it in here. You can see the slope for this first one is 8. The slope for this second one is that. And the slope for this last one is this. All right, so I'm going to make this into a decimal, or fraction rather. All right, we know that's weird, but that's repeating, so boom. So that one's this one. With this one, it's not repeating. It's an irrational one, so I know I'm not going to be able to make it a rational fraction, and there's no pattern for me to repeat. So this one I'm going to actually have to do by hand, but let me go ahead and label the ones that I know. So the one that had in the beginning, this -3, 9 and -4, 1. So this one right here, which is SR, so SR right here, that's going to be 8. Then the second one was the weird one, so I'm going to skip that one. And then the third one, which is this one, which is ST, is going to be -2/3. ST. So -2/3 for ST. And I can just use the line that's drawn here to find that slope. So what do I need? I'm going to zoom out a little bit, or zoom in. I need 2 corners, so obviously there are no corners right here. So let's just go until I find one. Geez, there's no corners. So obviously I'm not going to find those corners because this is not going to be a rational number. So I'm just going to write the slope as it is, which is 0.571. Yeah, I'll leave it right there. I do know, though, it's not the reciprocal of this. Like if I multiply these two, I'm not going to get -1. If I multiply these and this is not going to be -1. If I multiply these two, it's not going to be -1. So none of these make a right angle. All right, so triangle RST is an isosceles, okay, because 2 sides are equal. So let's look at that spelling, because that spelling sucks. Isosceles. All right, so you should be done with your question 2. And then finally for question 3, I just want you to tell me how will you go by proving that it's an equilateral right triangle. I'm telling you that it is. How would you prove that? What are the things that you would need to prove in order to see? And then again, given this, prove that it's a square. So we're talking about here the things that make it a square. So I need all the sides are equal. We can prove opposite sides are parallel. And then I also need the perpendicular pieces. What else you got? Given this, how would you need to prove that something is a rectangle? All right, so you're looking at a rectangle, what would you need to know? What are the key features? How would you prove a rhombus? How would you prove a parallelogram? So that's what this entire unit is about. Let's practice.